figure it out, but I might need a little bit of help from you guys. So maybe at the end of the hour, we can talk about the Gallon Man. And that will help you with your gallons, your quarts, your pints, your cups, your ounces, and all that kind of stuff. Okay? I know I remember, but she said, oh, I don't know if I remember. But that's okay. I'll show you. I do it with a big G. Really big G? Okay? And some of you, when you see it, I guarantee you're going to remember. But anyways, I want to show you what this is talking about because you could see something like this in your MCAs. And I know this is something that everyone in here, everyone can do this. Okay? This is an input-output thing that looks a little bit different. Okay? In fact, we can look at this right here, and we can create what we call a function table. Okay? And on one side of the function table, we have what we call our in, and the other side, we have what we call our out. Now, I just want to show you this because this is what's new for you. Your eyes need to be here so you can see this. Our input, when we're dealing with something like this up here with y equals 5x plus 3, our input is always considered x, and our output is always going to be considered y. Okay? And then we would consider this 5x plus 3. You guys remember, what's my rule? Right? What's my rule? I'm going to tell you right now, this rule is 5x plus 3. 5 times the value of x added to 3. Well, here it says right here, for x, we're going to use 1, then 2, then 3. So we're going to put in the value of 1. That's our input. We're going to put it into the expression or rule, and then we're going to tell what we get out. Okay? And we've done something like this. You've done something like this before when they gave you an expression 5x plus 3, and this would be in the instructions. And then it would say like number 1 for x equals 1. How many kids remember seeing for x equals 1? We've done a problem like this before. Okay? So we just put in this value of x. Now the only difference is that they have this lovely y here, this lovely x here, and this is essentially what they mean. We just need to be able to tie all those pieces together from input, output, what's my rule, and we need to understand that the rule is just an algebraic expression. Okay? And just like in science class, this rule is constant. And our variable is the thing that changes over time. We're going to try it as 1, then we're going to change it to 2, and then we're going to change it to 3. And what we get out will be our result. Does that make sense? Yep. So we're making a little connection there to science. So what is 5 groups of 1? 5. And then we need to add 3. 5 plus 3 is? So when we put in 1, we get out 8. You okay with that? I'd like everybody real quickly to try 2 and 3 and tell me our output values for when x is 2 and for when x is 3. Okay? Okay? There's one thing I know when we multiply by 5. Multiplication is just repeated what? Addition. Okay? So as long as this rule is constant and we're multiplying by 5, I bet you anything that this y is 13 and this y is 18 because I just have one more group of 5 here and one more group of 5 here. Okay? So let's see if that's true. 5 times 2 is 2 groups of 5, right? That's 10. Plus 3 more, and we get 13. 5 times 3 should give us one more group of 5, that's 15, plus 3, and we get 18. Okay? Now there's a second piece that we need to learn from all of this, and that is this. When we have an X value and a Y value, we're just going to let that ring. That's what voicemail's for, right? Okay? If it's really that important, they'll call back. All right. When we have an X value and we have a Y value, we can create something called an ordered pair. And on an ordered pair, we're going to work today on actually graphing. So when X is 1, Y is 8. That's our ordered pair. So if we went down to this graph right here, we could graph this ordered pair by going over 1 on the X. You guys should all know that this is the X-axis here, and this is the Y. We'd go over 1 for X and up 8, which would be somewhere probably up here approximately because my graph isn't big enough. Does that make sense? And I guarantee some of you saw things like that on your OPA test, right? They gave you a rule. It may have looked like this, and then they said, and graph that line, or graph the ordered pairs. We need to understand that our input is X, our output is Y, so this makes an ordered pair of 1, 8, because our ordered pairs are always X, Y. Okay? This ordered pair, what would the ordered pair be for this? When X is 2, 2 and 13, and that means on our graph here, we would just go over 2, and then we'd go up the y-axis 13 spots. Okay? And my ordered pair, when X is 3, Y is 18. Okay? And then we should be able to graph that. We follow the X first, because X always goes first. We travel 3 spots, 1, 2, 3 spots on our X, and then we'd go all the way up 18. Make sense to everybody? Those are all the things that we're going to be covering today. We're going to be talking about these expressions, the rules, inputs, outputs, and graphing. So we're going to put it all together today. You guys think we can do it?
Yes.
I know you can do it.
It's easy.
I know you can. We just have to make some connections to other pieces, all right? So this says use the given X values to write the solutions of each equation as ordered pairs. When X is 2, what does Y have to be based off of this graph right here? When X is 2, I'm going to show you the first one, and then you guys are going to do the other ones, all right? So if X is 2, that means we travel over 1, 2 spots, and then I'm going to go all the way up to where that line is, because right here is the ordered pair. So over 2, up 4, my ordered pair would be 2, 4. Okay? So you tell me when X is 1 and when X is 0, what is the ordered pair? And just keep in mind that ordered pairs are always X first and Y second. Okay? I'll give you a few moments. I know. When X is 1, so we're at 1, what point does the line cross? What is the Y value?
1, 2.
When X is 1, Y is 2.
1, 2.
So we'd write this ordered pair as X being 1, Y being 2 in parentheses. Okay? Now, when X is 0, Y is?
0.
Does anybody know what, if we're on 0, 0, does anybody know what that's called? Go ahead. It's called the origin. Origin. Okay? Now, I want to show you something. I'm going to create something like this right here. And I want to see if you can determine what the rule is. Okay? So we're going to play What's My Rule? Okay? So let's try this. When X and Y, input, output, right? When we put in 0, we get out 0. When we put in 1, we get out 2. Very good. And when we put in 2, we get out 4. My question is, what's my rule, or what is the expression that matches up with this line and these input-output values? I'll give you a few seconds to try, okay? All right. If you said my rule is times 2, times 2, you're incorrect, but you're so close. I would agree. If we take 0 and multiply it by 2, we get 0. If we take 1 and multiply it by 2, we get 2. If I take 2 and multiply it by 2, I should get 4. But to describe this rule, I need to use x.
That's what I was gonna say.
Okay? So we need to describe this rule as 2 times x, or x times 2. It doesn't matter because it's multiplication's commutative. X times 2 or 2x, doesn't matter. Doesn't matter the order. And yes, I just heard this up here. Look at this. We could say that our output y is equal to 2 times x. Okay? Now those are all the things that you're going to be responsible for on your MCA for 6th grade. Describing the rule as an expression. Okay? And that rule is not just times 2. That's why maybe I should put the little dot in here. It's 2 times x, or x times 2. We have to include that input value. So now that I know, I can put this 0 in for this x. I can put this 1 in for this x. I can put this 2 in for this x, and I get out my value of y. Okay? So just a little bit different than what you saw from everyday math. Is that correct? Okay? And then we know that we can go through and take these ordered pairs and say 0, 0. It's right there on the origin. It's right there. See that? And 1, 2. I go over 1, up 2. Boom, there it is. And when I go over 2 on x, 2, up 4. There it is. Your homework tonight will look very similar to that.
Woohoo!
Okay?
Yeah.
Oh. I'll do the first one for you. I'll do the first one for you. That was a student. He sounded like a truck backing up. Hear that? See? They thought exactly. Watch. Amanda is. Amanda is. Everybody agree? Is means equals. Okay? Now it says 7 years younger. So I heard someone say we need to subtract 7. That's 7 years younger. And then her cousin. So that's her cousin. Okay? Now, more importantly, we should be able to determine which one is our x value and which one's our y value. Now, our y value is always our output, so Amanda's age is our output on this one. Okay? Our input is the cousin's age. Does that make sense to everybody? So if we look at a graph that you would make in science class, we know that this down here is the x-axis. This up here is our y-axis. We would label this as Amanda's age, and this is the cousin's age. And then we could determine Exactly. Anytime we get the cousin's age, we should be able to tell Amanda's age, right? Because we just put in the cousin's age and we'd get out Amanda's age. Everybody with me? How about if I told you Amanda was 6? If Amanda is 6, how old is her cousin? If Amanda is 6, if I say Amanda is 6,
What?
how old is her cousin? Amanda is 6. How old is her cousin?
Oh, 13. 13. How do you?
Now, eyes here, kids. You could see one like this. This would be a little bit higher level question on your MCA. But now what we have is this. We know that A is 6, and that is equal to the cousin minus 7. The kids that are getting 13, I don't know if they necessarily knew this or not, but they said, well, just add 7 to 6. So in other words, Amanda's age plus 7 will equal the cousin's age. Is that correct?
Yeah.
And it's all because of inverse operations. So let's look. Remember how we want to get a variable by itself? Want to get a variable by itself? Add 7 to both sides. Whatever you do to one side, you have to do to the other. The cousin is 13 years old. I promise you, you could see one like that on your MCAs as well. Okay? So now, your job for number 7 is just to write something like this right here. Okay? You don't have to do any solving because you can't. There'll be 2 variables. But you need to write an algebraic equation. It's an equation because it has an equal sign. See if you can do that with this population question with North Carolina and South Carolina. Go. Thing is S times 2. Okay? So we should be able to understand the inverse piece here. For me to get to North Carolina divided by 2 equals South Carolina, I would just divide by 2 on both sides, and then I would have this exact piece right here. So we need to make sure that we understand that so that if they actually gave us North Carolina's population, or if they gave us South Carolina's population, we could use either one of those equations to solve that problem. Okay? All right. The next 2, if you're up for a challenge, we'll do the next 2. I think let's just try number 7 on your own right now. Try number 7. I'll read it to you first because that might help you. Because I know for a fact. Okay, what's your answer? $7 what though? $7 per. So we have to do 7 times our book, or 7x, because we don't know how many books are going to buy. Could be 1, could be 2, could be 3, could be 4, could be 5. Okay? And we can put that in at any time. 7x plus $2.75 would give us our total cost every single time. Okay? Okay? Now I want to just circle this piece right here. $7 per book. Anybody know what that's called? $7 per book. Anybody know what that's called? Let me state it one more time. $7 for one book. That's okay. We learn from our mistakes. Everybody agree that it's $7 for one book. Dollars per book. How much would we pay for 2 books? 14. How much would we pay for 3 books? 21 bucks for 3 books. Now we'd have to add our $2.75. Okay? This is called a unit rate. Everybody see this as a unit rate here? $7 for every book. For every one book, it's $7. So for 2 books, you're going to pay $14. For 3 books, you're going to pay $21. And then we just have to add $2.75 to get our total cost. Okay? So this unit rate, when we see unit rates, that is going to tell us what we're multiplying by our X value right here. See how I labeled books down here? And look at books is on the X value. 7 times our number of books will tell us the price for this, and then we just add $2.75. Okay. We actually have to do 1 squared first. 1 squared is 1 times 1. 1 times 1 is 1. Then we need to take 2 and multiply it by 1 squared, or 1. So 2 times 1 is 2. 2 times 1 is 2. Plus 3 more, our value is 5. Okay? So when X is 3, you cannot do 2 times 3 first. You have to square 3 first because of the order of operations. Parentheses first, then exponents, then we multiply or divide, and then follow it up with adding and subtracting. So make sure. So what is 3 squared? What is 3 squared? What's 3 squared? 9. 9 times 2 is? 9 times 2 is 18. 18 plus 3 is? 21. Remember, this part must come first. Okay? 5 squared. What is 5 squared? 5 squared's not 10. I was waiting for it. I've been waiting for that incorrect answer all day. 5 squared is 5 times 5. 5 times 5 is 25. 25 times 2 is 50. 50 plus 3 is? Very good. I promise you, you'll see one just like this, or very similar to it. All right, 7 squared. No, we did it again. Are you kidding me? 7 squared is not 14. 7 squared is 7 times 7, and it's 49. Now, if we take 49 and multiply it by 2, we get a grand total of 98. 98 plus 3? 101. Unbelievable. Okay, now we're going to put it all together. I want to see if you can fill out this chart on your own, and then we'll talk about the graphing. Okay? So, Mr. Martin runs at a whopping 5 miles per hour. Man, am I moving. That's not running. It's not jogging. It's more of a slog, a slow jog. No, it's a slog. It's called the slow jog. So Mr. Martin is slogging. At 5 miles an hour, he's slogging. Okay? Create a function. Sorry, this is in the way a little bit. Create a function table to show the rule and distance traveled for 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. Okay? So I need to know what's the rule. fill in your input values. Tell me what I get out, and we'll be graphing that in a little bit right over here. I'll give you a hint. Our input values are right here. 1, 2, 3, 4, 5. When I run 1 hour, how far will I travel? 5 miles. Everybody agree? How do we know that?
1 times 5 times the last
5 miles per hour. So Zoe, when I slog for 2 hours, how many miles will I have traveled? 10. Zoe, can you tell me what my rule is? Would everybody agree that X is hours? If we do 5 times our number of hours, 5 times X. Now keep in mind this could be 5 times X, or we could write it as 5X, or we could write it as X times 5. Either one of those works. Okay? Here is my unit rate, 5 miles for every 1 hour. We're going to take 5 miles and multiply it by every hour that we travel. So when we get down to 5 hours traveled, we would travel, or 5 hours of running or slogging, we'd travel 25 miles. Okay? So we know Y should be labeled what? What should the Y be labeled?
Y is miles.
Say it again, miles. All right. So now, today you're going to do this exact thing for homework. You're going to have to come up with the rule. You're going to have to put in your inputs, your outputs, and then you have to graph it. And some of you are going to say, Mr. Martin, this is just like science. Well, yes, of course it is. Okay? What is this called right here? The y-axis. What is the y-axis labeled? Miles. So yes, I'm going to, just like your science teacher, I'm going to require you to label both axes. What does the x-axis have to be labeled then? Hours. So now I'm going to put in my input as 1, 2, 3, 4, 5 hours. And now I'm going to set up my intervals for my act. Who can tell me what should I label each one of these? Yeah, by 5s, right? 5, 10 miles, 15, 20. And why did you pick 5? How come we didn't count up by 1? Wouldn't have enough space because we're traveling 5 miles an hour, right? Okay. So now watch this. If X is 1 and Y is 5, isn't my ordered pair 1, 5? Is that right?
Yeah.
So don't I go over 1 and up 5? I'm right there. Okay? When X is 2, Y is 10, my ordered pair is 2, 10. So I go over 2, up to 10. There I am. You're right. It causes a straight line. And anytime we see a straight line like this, we're going at a constant speed. Okay? Then I'm going to show you one other thing, and then I'm going to hand out your homework. 3 hours, we would be at 15 miles, because 3 times 5 is 15. Okay? At 4 hours, we would travel a grand total of 20 miles, and 5 hours would be 25 miles. And we would form that straight line, and anytime we see a perfectly straight line, that is a constant rate of speed. Now, I want to show you there is a ratio here, and I'm going to show you the equivalent ratios. Ready? 5 miles for every hour is equal to 10 miles in 2 hours. See that? 5 to 1 is equal to 10 to 2. That means we travel 15 in 3. Have you guys seen this before?
Yes.
Yeah. So hopefully we can see this proportional relationship between our miles and hours. In fact, for every 1 hour, we go up 5 miles. For every 1 hour, up 5 miles. For every 1 hour, up 5 miles. So that unit rate tells you quite a bit about what your rule is. Does everybody see the relationship between unit rate of 5 miles per hour, eyes here, and your rule right here? Your unit rate's going to set up your rule. Then you can easily put in any number and get something out, and you can graph it on there. Does that make sense to everybody?
Yep.
Okay. Now I will have this video available for you.